This is more about infrared from the P2 topic. Again, this is triple only. Let's just have a quick recap about what we knew about infrared already. We know that all objects emit and absorb infrared. And we know that if they are at a constant temperature, then they emit and absorb at the same rate, which we know from earlier on this topic anyway. We know about thermal equilibrium, that the thermal energy is being given out at the same time as it's being absorbed, which is why something stays at a constant temperature. So let's just take this thought process a little bit further, that if it emits at a higher rate, so faster, rate than it absorbs, then we know that the temperature is going to decrease. Okay, so if you don't want the temperature to decrease, you're going to need to change something so that it's not emitting at such a high rate. An example of this is using the shiny foil blankets. So particularly for marathon runners, or if someone survived an accident, or like mountain rescue use them as well, for people who've had kind of injuries or accidents that they've then had to kind of rescue. So what they do is, because it is shiny, it emits less radiation in the same amount of time, so it decreases the rate of emission. Now we can move on to thinking about the opposite of this. If it absorbs at a higher rate than it emits, then the opposite is going to happen, and the temperature will increase. Again, the example that we want to think about here that's often brought up is global warming. You did about this in year 8, but we're going to recap now. So let's imagine that we have the Earth, and the Earth around it has an atmosphere. Okay, so let's think about what we know. We know that lots of radiation comes from the sun. Some of that radiation is going to be absorbed straight by the Earth. Some of it is going to be absorbed by the atmosphere. Some of it is going to be reflected off the atmosphere. So not all of it is going to be absorbed or transmitted. Some of it will be reflected as well. So that's coming into the Earth. The other thing that will happen is that the atmosphere will emit some radiation itself. So remember, we talked last lesson about absorbing and emitting radiation. We know from our recap, all objects emit and absorb infrared radiation. So the atmosphere of the Earth, all those gases that surround the planet, are going to absorb some radiation, and they're also going to emit some radiation as well. And the same goes for the Earth. We know that it's absorbed some radiation, so it will also emit some radiation as well. Okay, so in a very basic way, if we're absorbing it, the temperature is increasing. If we're emitting it, then the temperature has a potential to decrease. Let's think about it like this. So we have infrared is absorbed by the Earth, so by the ground, and then the Earth re-emits this radiation. and it is a longer wavelength. So the wavelength decreases, okay? And then in the atmosphere there's certain gases. So the gases are carbon dioxide, water vapour, methane, and these are all really good absorbers of the radiation, okay? So these absorb the infrared radiation, so either that's coming in from the sun or that's being emitted by the ground, and then re-emit it back to the surface. So if it wasn't for the atmosphere, it would the earth, the ground, would be absorbing the radiation from the sun and then re-emitting it back into space, which would mean that at night time it was much colder, because during the day it's going to be absorbing and emitting, whereas at night it's not going to be absorbing any because the sun's not going to be shining on that part of the earth, so it's just going to be emitting, and it would get very cold, so cold that life wouldn't be possible. So let's just have a quick kind of thing about this. This process is called the greenhouse effect, okay, and it is necessary for life to kind of live on Earth, because otherwise it would be too cold for life as we know it to live. The problem is that it has to be a very careful balance. Okay, so we need the greenhouse effect in order for us to be able to, for the Earth to be at a temperature that we can live on. But the problem that we have at the moment is that this balance is not careful enough. So what's happening is we have these gases. Okay, so these are called greenhouse gases. And by them increasing, then the amount of infrared increases on the Earth's surface, on the ground, and the average global temperature increases. Right, so the average global temperature increasing is what we refer to as global warming. You need to be able to give some of the effects of global warming, and say kind of what might be happening, what is happening around the Earth due to the average global temperature increase because of the increase in greenhouse gases. So if the average global temperature increases, then the ice caps, so by ice caps we mean at the poles, and lots of ice on land as well, melt, which puts lots more water into our oceans, which means that sea levels rise, which means that some habitats are destroyed because there's flooding, there's extreme weather. So what do we mean by extreme weather? Well, we can be talking about droughts, we can be talking about floods, things like, there's evidence that things like hurricanes have got worse as well, and then things like crops, because of things like drought and flood, crops have failed in some places around the world, or the seasons have changed. So for example, in places where it used to be quite warm in the summer, if it's now much hotter in the summer and much drier, they can't grow the same crops, so they'll have to grow them at different times of the year, because otherwise they will fail. So you do need to be able to give some suggestions. I mean, these aren't the only ones, but these are just probably the easiest ones to kind of memorise and think about.
Setting the scene.
You probably already know about the greenhouse effect, global warming. The average temperature of the Earth is rising because of increased amounts of carbon dioxide and other greenhouse gases in the atmosphere. This activity focuses on the physics behind global warming, helping you to understand it in terms of the emission and absorption of radiation by the Earth. You've learnt about black bodies, which are perfect absorbers of radiation. These have a characteristic emission spectrum, whose peak wavelength depends on the body's temperature. So just note here that this is referring to that graph from last lesson where it's that bit that kind of where the intensity is, that there's a peak wavelength here. You've also learnt that if an object absorbs more radiation than it emits, then it will get hotter, as long as there are no other types of energy transfer happening. Our planet behaves a lot like a black body. Although it is not a perfect black body, it reflects about 30% of the radiation which falls on it. By thinking about the Earth as a black body, we can understand the greenhouse effect in terms of the balance of radiation absorbed and emitted by our planet. So read through the information and answer the questions below, which guides you through the steps involved in the process of global warming. Look at the diagram below and write numbers next to the matching descriptions. So on here we've got 1, 2, 3 and 4. And our descriptions are: the temperature of the atmosphere increases. Most wavelengths from the sun's electromagnetic radiation go through the Earth's atmosphere. Greenhouse gases in the atmosphere absorb some of this infrared radiation. The short wavelengths electromagnetic radiation is absorbed by the Earth's surface, which warms up. Energy is emitted by the Earth as longer wavelength infrared radiation. The only way that energy transfer can take place between the Earth and its surroundings is by radiation. Explain why energy cannot transfer to or from a planet by conduction. Use the 3 phrases to complete the sentences below. So less radiation than, more radiation than, the same radiation as. The sun is a black body whose spectrum peaks at visible wavelengths. These wavelengths pass through the Earth's atmosphere and are absorbed by the Earth's surface. The absorption of radiation warms the surface, which then emits mainly the infrared part of the spectrum. Explain why the peak wavelength emitted by the Earth is longer than the peak wavelength emitted by the sun. Give one reason why the amount of carbon dioxide in the atmosphere has been increasing. So this one is putting more carbon dioxide into the atmosphere, and this one is reducing the amount of carbon dioxide that's taken out of the atmosphere. Carbon dioxide and other greenhouse gases, such as methane, absorb some of the infrared radiation coming from the Earth's surface. The greenhouse gases then emit the radiation again, but in all directions, including back down to Earth. Use the paragraph above to help you explain why an increase in greenhouse gases leads to an increase in the Earth's temperature. State one problem which global warming could cause for humans. Greenhouse gases are important to life, as Earth would be much colder without them. Explain why. Seawater absorbs radiation better than ice, whilst ice reflects radiation better than seawater. State which behaves more like a black body, seawater or ice. A black body is a perfect absorber and emitter of radiation, so seawater is more like a black body. As the Earth's temperature warms, we expect the amount of ice floating on the sea, mostly in the northern polar region, to decrease as more of it melts. Observations show that this is already happening. Suggest why the melting of sea ice is likely to speed up global warming. Well, we've just been told that ice reflects radiation, so if there's less ice and more seawater, then even more radiation is going to be absorbed. The temperature of an object increases if it absorbs more radiation than it emits. The Earth's temperature depends on a lot of factors, including the absorption of infrared radiation from the sun and the emission of radiation from the Earth's surface and atmosphere.